Hello and welcome to Uncle Matt Online Academy. In today's lesson, we are going to continue with our discussion on probability. In the previous lesson, we defined probability and talked about terminologies in probability. We defined probability as the study of uncertainty or the study of chances in an event. And we talked about terminologies like mutually exclusive events, independent events, possible events, impossible events, sample space, and others. In today's lesson, we want to talk about what is known as probability diagrams, that is probability table and probability tree, and we also solve calculations involving probability. So we are looking at probability table, and then probability tree, and then we also look at probability or calculations involving probability. So let's start with a probability table. What is probability table? A probability table is a table of values that is created to represent or show the sample space in an event. Like when we toss a coin, we know that the possible outcomes are head and tail. Then putting these outcomes in a table is what we call probability table, or a table that is created to represent these possible outcomes. It is known as probability table. When we roll a die, the possible outcomes are 1, 2, 3, 4, 5, and 6. These are the numbers we can get by rolling a die once, and that represents the sample space. Now creating a table and then putting the values in the table that carries the sample space or that carries the possible outcome is what we call the probability table. This is very helpful or very important when we have, like, when we roll two dice or we toss two coins. When two events are done the same time, this probability table is very important in helping us to see all the possible outcomes. Without a probability table, we may not be able to see all the outcomes in an event or in a complex event easily. But probability table helps us to see all the possible outcomes or the sample space in a complex event, to see it very easily. For instance, when we toss a coin 2 times, the way we represent it in a probability table is that the first one we represent it in the vertical row, and the second one we represent it in the horizontal row. So let's say we have first coin and we have second coin. You know that every coin has two sides, that is head and tail. So we represent the sides head and tail. The second one, head and tail. Now we combine the outcomes that can come by tossing these two coins together. If we throw the first coin, it is possible that we get head, and then if we throw the second one, it is possible that we still get head. Or we get head in the first one and get a tail in the second one, or we get a tail in the first one and get a tail in the second one, or get a tail in the second one and then a head in the first one. So this table, see how we are going to use it to create the outcomes. What we do now is that we combine this one, this side with this side. That will give us head and head. This one is head here and this one is head here. And then we combine also, we take this one again to this side, we combine it with this one, and that will give us head and the tail. Then we pick this one, we combine it with this one, and that will give us tail and head. And then we take it to this side, we combine it with this one, that will give us tail and tail. So the outcomes are going to be head and head. You combine with this one, we have head and tail. With this one, we have tail and head, and this one we have tail and tail. So these are the possible outcomes in this event when we toss two coins together. This is the sample space. These are the outcomes or the possible outcomes we can get by tossing two coins together. So in this sample space, we can see that we have total of 4 events. 1, 2, 3, 4. We have 4 events inside the sample space. So the numbers in our sample space is equal to 4. This represents this thing is now the probability diagram for tossing a coin 2 times or for tossing two coins together. This is the probability table. The same way, if we roll 2 dice together, see how we create the probability table. We have the first one and then we have the second one. Now we have 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. That means that the first coin, the first die, has 6 sides. It is the sides that we are now representing here. We represent the sides of the first die and then the sides of the second die. After representing, so having the sides represented, now we look at how we can combine the sides or we can combine the outcomes. So we have the first one, now creating the outcomes. In creating this table, we put this one, the first one in the vertical row, and then the first one in the horizontal row, and then first one in the vertical row and second one in the horizontal row. We continue like that until we get to the end. So this one is going to be, oh sorry, we don't draw this very well. This is going to be this, and then this is going to be, let's start 1, 2, and this is going to be like this. Okay, so we draw the outcomes. Here we combine this one with this one, so we have 1, 1. We combine the one with 2 here, we have 1, 2. We combine the one with 3 here, 1, 3, 1, 4, 1, 5, 1, 6. Then pick the second one, that's the second row here. 2, we combine it with the first one on top. 2, we combine it with the second one on top. 2, 2, 2, 3, 2, 4, 2, 5, 2, 6. Then we pick 3, 3, 1, 3, 2, 3, 3, 3, 4, 3, 5, 3, 6. Then pick the fourth one. This goes for this. This goes for this. This goes for this. And then for 4, we have 4, 1, 4, 2, 4, 3, 4, 4, 4, 5, 4, 6. This 4 goes for this, and then 5 we have 5 1, 5 2, 5 3, 5 4, 5 5, 5 6, and this 5 goes for this line, that's this row, and then 6, 6 1, 6 2, 6 3, 6 4, 6 5, and then 6 6. Okay, so we have 6 6, 6 6. Okay, so this represents the probability table when two dice are rolled together. Now the probability tree. Probability tree is another form of representing the outcomes or the possible outcomes in an event, but the probability table is more common. Sometimes we represent the outcome this way using a structure that looks like a tree or like a family tree. For instance, in an event where we have two coins tossed the same time, the first one, we know that the coin has two sides, so we represent each of the sides with a leg. So this leg we have head, and this leg we have tail. Then the second one, in the second time, each of the legs will bear two legs. So this one will bear two legs. We have head and we have tail, and this one also bears two legs. We have head and we have tail. Now to get the outcomes, we combine this and this, then we get head and head. Then we combine this one and this, we get head and tail. We combine this and this, and we get tail and head. We combine this and this, we get tail and tail. That is the same outcome that we have in this one, the same outcome, but this one is called probability table, while the other one is called probability tree. So this one is probability tree. So you see the difference between probability table and probability table. Now let's look at calculations in probability. If we are given any question to solve or to calculate something in probability, this is the way we determine the probability of any event. Probability of an event or a number is equal to the event required all over sample space, where this event required is what you are looking for. This event required can be 1, 2, 3, or 4, or like in this our probability table. In our probability table here, we can be asked to find the probability of getting tail and tail, that is 2 tail, or probability of getting 2 head, or probability of getting head and a tail. So each of the ones we are looking for is the event required, and then the sample space is the total possible outcome in it. Now for instance, example 1. Example 1. If we have that supposed that a fake die, suppose that a fake coin is tossed once, what is the probability? What is the probability What is the probability of getting one head? What is the probability of getting one head or getting a head? What is the probability of getting a head? Now solution. When we want to calculate the probability of getting any event, what we have to do first is to get the sample space, the total number of possible events, and then we get the total number of events in the one we are looking for. Now for instance, in this case we have the sample space when a coin is tossed once is, the sample space is going to be, we get head or we get a tail. So the sample space is only 2. We can either get a head or we get a tail. So sample space is equal to 2. We have 2 events in it. Now we are looking for the probability of getting a head. That means in this sample space we look for the total number of heads. We have only one head in this, so head is equal to 1. Therefore, the probability of getting a head, which will represent like this, probability of getting a head, is now equal to the total number of heads in the sample space. It is equal to 1 all over the total number of events in the sample space, which is equal to 2. So the probability of getting a head is 1 over 2 in the equation. So this is the answer. Example 2. In this example, we have that suppose that a fake coin is tossed twice. Suppose that a fake coin is tossed twice. Suppose that a fake coin is tossed twice. What is the probability? What is the probability of getting at least one head? What is the probability of getting at least one head? Now we draw our probability table. Solution. We have the first one, it has 2 sides, head and tail. The second one, it has 2 sides, head and tail. Now we combine the first one and first one here, head and head. First one and second one here, head and tail. Second one and first one here, tail and head. Second one and second one have tail and tail. So these are the possible outcomes. So that means that the sample space, the number of events in the sample space is 4. 1, 2, 3, 4, like we've seen before. So we have 4. Now the question is, what is the probability of getting at least one head? What it means is this: we go to the probability table and look for the ones that contain at least one head. This one contains at least one head. This one is 2 heads, which means that it even has more than one head. So anyone that has from 1 head and above, we count it. This one has 2 heads. This one has 1 head and a tail, so it is among. This one, tail and a head, so it is among. So the only one that is not among is this tail and tail. So we count the ones that have 1 head, at least 1 head. They are 1, 2, 3. So we have 3 in the event we are looking for. The event we are looking for is the probability of a number, or the probability of an event that has at least 1 head. So which will represent like this: probability of an event, at least one head. Now this is equal to the total number of events with at least one head, which is equal to 3, all over the total number of events in the sample space. The sample space we have 4, so it is equal to 3/4. This is the answer. This is the answer. Now, example 3. If a die is rolled, what is the probability? What is the probability of getting a at least getting an what is the probability of getting an even number, and B, an odd number, Okay, so the probability of getting an even number and probability of getting an odd number. Solution: what we do is that we first of all get the sample space or the probability table for it. It's just one event, so we don't really need to draw the sample space. We don't really need to draw the probability table. Probability table is needed mostly when we have two events that are done at the same time. It helps us to see all the events, all the possible events clearly. Now, when we have just one event, like when a die is rolled once, we can draw the sample space easily. We can get the sample space by saying that we can either get 1, or we get 2, or we get 3, or we get 4, or we get 5, or we get 6. So this represents the sample space. Now what we do now is that in this sample space, to answer question number A, an even number, we look for the events that are even number in this sample space. An even number is a number that can be divided by 2 without remainder. 2 can be divided by 2 without any remainder. 4 can be divided by 2 without any remainder. And 6 can be divided by 2 without any remainder. So we have 3 numbers that can be divided by 2 without any remainder. We have 3 even numbers in this sample space: 1, 2, and 3. So the number of events in the ones we are looking for is 3, while the total numbers in the sample space is 1, 2, 3, 4, 5, 6. We have 6 number of events in the sample space. Therefore, the probability of even number is equal to 3/6, and this gives us 1/2. Now, to answer question number 2 or B, an odd number, we come to the sample space again. We look for the odd numbers, that is the numbers that cannot be divided by 2 without a remainder. 1 cannot be divided by 2 without a remainder, without a decimal point. 3 cannot be divided by 2 without a decimal point, and 5 cannot be divided by 2 without a decimal point. So these 3 numbers are odd numbers. So we have 3 odd numbers again here, and the total number in the sample space is 6. So we say the probability of getting an odd number is equal to, we have our sample space is equal to 6, and total odd number is equal to 3. So we have 3/6, now which still gives us 1/2. So this is how to get the probability of odd number in this question. So in this lesson, we've learned how to get or how to draw probability table, and how to draw probability tree, and then how to solve calculations involving probability, and I believe that the concept given to you is very clear. Thank you.